Hello everybody, my name is Mateo Osorio, and today I'm going to be presenting my Rube Goldberg device for a science class final project. Right now I'm going to describe how it's all going to work, and then you can understand it, and it's going to be awesome. Okay, let's go. So the ball's going to roll down that ramp, it's going to hit out the Jenga block, it's going to fall down, it's going to dip over that, which makes the marbles, which rounds on the other side. Here to go in the cup's going to activate the lever, which is going to release the ball, which is going to hit the switch, which is going to inflate the balloon, which is going to release the Formula 1 car, which is going to go down the ramp, and the car has a needle attached to it, it's going to pop the balloon, which is there on that string with the green chair, which is gonna release the skateboard, which is gonna hit a stone, which is gonna crush a soda can. Alright, you ready? Let's do this! Alright, the ball's running down, it's gonna hit the... Wait, no, why you not go in the cup?
Take number 2.
Alright, you're gonna go roll down and you can do it. Oh wait, why you stuck in the tape?
This continued on for several hours.
Ay.
But then, the moment of truth came. The ball rolls down perfectly, hits all the Jenga blocks with style, tips the thing over the ball on the cup goes off, the switch goes on. The switch releases the Formula 1 car, and I was like, oh my god! I got my doggy screaming!
Thank you all so very much for watching. Here is a funny picture of a guinea pig. Thank you. And Mr. Nick, you probably want to keep on watching because now I'm going to explain all the boring physics stuff. These are all the simple machines that can be found in my Rube Goldberg device, as well as the steps. So the first step is this inclined plane. At this point, the marble has a potential energy of 0.098 joules. The law of conservation of energy also applies to this scenario, because the energy that is being displaced by the ball as it is falling and hitting the Jenga blocks isn't all being destroyed. It isn't not being destroyed. It is just being turned into other forms of energy, such as sound. Steps number 2 and 3 are this inclined plane and this lever. Step number 4 is this other lever, which is being balanced by a stick and it has cups on either side. This is my third inclined plane as the marble rolls down it. Then it hits the switch and turns on the balloon fan. This is also an example of Newton's third law, which states that every action has an equal and opposite reaction. This means that as the marble hits the switch is also pushing back with as much as energy to the ball as the ball does to the switch. It's also an example of Newton's first law, which states that every object is at rest until acted on by an outside force. In this example, the object that is at rest is the marble at the top of those books, and the outside force is the cup, which pushes it up, making it go down the ramp. It is also my fifth step. Now, in this car part, there are actually 3 steps. Number 6 is inflating the balloon, which is an easy task. Number 7 is the wheel and axle on the car. And number 8 is the wedge attached to the tip of the car. So those are the 3 steps. Now, the kinetic energy of the car as it goes down the ramp is 0.065 joules. The speed of the car is 2.6 meters per second. The acceleration is 1.3 meter per second squared, and the force is 0.065 joules. Newton's second law applies to this because that's how I calculated the force, which is 0.065 joules. And it is also a vector because it is moving at a speed which is 2.6 meters per second, and it is going in a certain direction, which is kind of diagonally down and kind of straight forward, which I think is north. And also the momentum is 0.06 meters per second. Step number 9 is the popping of the balloon. Step number 10 is a pulley which goes through the holes in the dog cage that is supporting the box. Step number 11 is the wheel and axle on the skateboard. And step number 12 is the crushing of the can.